All right, well, the next part of linear regression is actually making sense of our equation, our line of best fit. And we do this a number of different ways. One is making sense of the slope. And what we do is we call that interpreting the slope, actually in what we call context. And context just means in this situation in terms of what our variables are. So in this case, our slope is negative 1,175, and I'm going to go ahead and put that over 1. And the basic definition of slope is delta y over delta x. That's how it works in math just in general. So in this case, though, what is y? Well, y is price. So it's really the change in price over the change in age. So what we would do is we'd say something like this. First of all, when we create these equations, they're just models. So we always say the model suggests. It's really no guarantee that anything's going to happen for sure, but we say the model suggests. And now we put that number for our slope into context. So we're talking about price changing this much. So the model suggests that price decreases, and the reason why it's decreases is that our slope is negative, so we say decrease instead of increase, and it would be $1,175 because that was our unit here, and then it's per, and then it's one change in age, so per 1 year increase in age. So that is how sloping context works. Now what about y-intercept? Well, the y-intercept is always defined as 0, comma, something. So if you were to plug in a 0 for x in this equation up here, what will we get? Well, we get 13,850 for y. So in context, what we'd say is this. We'd say the model suggests. Now x is something here. X is not just x is actually age. So the model suggests that a brand new car, because that's what a car would be if it was 0 years old, so a brand new car would cost how much? It's whatever the y is. So how much would it cost? It would cost $13,850. So that's what the y-intercept actually means in context. This point means this. The model suggests that a brand new car would cost $13,850 according to the data we had. Alright, so here's another thing you might get asked to do. Instead of interpreting the slope and the y-intercept, well, what about r squared? Well, we know what r is, so how would you find r squared? So to find r squared, it's simply taking r, which is negative 0.94, and squaring it. So if you grab your calculator and do this really quick, you should get 0.8836. And another thing you should realize is that the lowest this could possibly ever be is 0, and the highest it could possibly ever be would be 1, because the highest r could be would be either 1 or on the negative side would be negative 1. So r squared will always be a value between 0 and 1. So here's how interpreting this in context works. What we do is we say differences in, okay, and then what we do is we say all the time whatever the x variable is. So our x variable is in age, so differences in age, explain, and then it's a certain percentage here, and that percentage is based on r squared. So this number up here as a percentage would be 88.36% of the variation in whatever our y variable is. Well, what is our y variable in this case? Our y variable is price. So that's what interpreting r squared in context would mean in this case. And so I'm just throwing out an example here. Let's say I had a car that was 2 years old and it cost $14,000. And let's say I had a different car that was 3.5 years old that cost, say, $10,200. So really what we're saying is, hey, this difference, the difference here is 1.5 years, explains a certain percentage of this difference, which by the way is 3,800. And it explains nearly all of it. It explains close to 90% of this difference here explains almost 90% of that difference. Now there's maybe another difference in here. It could be, you know, how well the car's been kept up or what model or whatever. But that's what r squared in context is about, is how strong of a model this is for predicting as well. Finally, what about describing the association? Well, from our slope over here, we know it's going to have a negative association. So I would definitely say negative in this case here. And then what happens is we would say this. As our x variable goes up, so as age increases, because it's a negative association, what that means is our price would decrease. So those are the basics in interpreting slope, y-intercept, r squared, and also the association in context of the variables in our situation here.